So you see that, okay, now the one thing you have to understand is there are many very different people doing mathematics. Okay, so whatever the way I'm functioning is by no way a universal rule, it's just me. And it's sad because it means that there is no algorithm to become successful, right? Because we are all different and we all have to find our way. Now, I'm a terrible learner. I'm a very slow learner. So it doesn't work at all if I read a book and I don't assimilate it. I have to get hand-on problems to really focus on them and really understand the stuff. So how do you get hand-on problems when you don't understand the whole thing? Well, you ask other people. So I go to conference and I ask, my friend, what's your problem? And then people ask you specific questions, and then I study them. Now, when they ask a specific question, very often it's of the type, I have property A and property B, does it imply property C? Quite natural. So what you really want, you want to find order in the world. Now, order in the world means property A plus property B implies property C. That's something nice you can build upon. But the sad thing is, this doesn't happen so often. Usually, well, it's not true because for some reason you didn't think about so easily. And the reason is that somewhere in the mountain, in the dark cave, there exists a strange object which shows that your conjecture is not true. And this strange object may not be so interesting beside proving that the conjecture is not true. Okay, it's good to know. So, and also since it answers a non-trivial question, the good thing is you can write a paper and usually you can publish it. And it's very important when you start to be able to publish papers. That's how you build your reputation. And the more papers you have accepted, the closer the referee look at your paper, and the better, the more fairly you get treated. Which is one of my concerns about artificial intelligence, because it already happens now from I don't know anything about artificial intelligence, but my conversation with my friends, it appears that artificial intelligence is already good at answering a number of easy questions. And my concern is that if you don't let the young people answer easy questions while they are learning, then they cannot learn. They cannot become professional. And it's a very great danger. So it's a little bit too early to see if this danger is a tsunami which is going to ruin all the profession. I don't know, but there is a chance for that. Okay, so that's why I mentioned that. You see, I'm not ashamed that I wrote 300 papers. I'm not ashamed to say that 100 or 150 of them had zero impact. It's not that they are wrong. It's not that they are completely uninteresting. They do small things, and they were very helpful because they gave me self-confidence. While doing them, I learned some things which I could use to do better work. So even though this had zero impact, this was important for me to do. So I have one advice to young people: whenever you have something to say, don't be shy, write it down and try to publish it. No harm done, okay? So going back to these many problems I try to solve, well, the sad thing is, okay, you get all these counterexamples, which are usually not interesting, but once in a while they are not completely uninteresting. The oldest problem I solved was called Maram's problem from Dorothy Maram. And when I solved it, it was 47 years old. So they had a conjecture, basically going back to von Neumann, because so it's a very respectable thing. And sadly, it's a counterexample, which means a nice conjecture doesn't exist because there are some object which unexpected existence. So it's not completely uninteresting. These objects are difficult to construct. Maybe one day they will have some use, but not now. So at least it had a good point that it stopped people trying to solve this open problem. Now, you see, when I started understanding more some basic objects, then I made myself some conjecture. And since these were I really had some understanding of what's happening. I've been luckier with my own conjecture, in the sense that now the paper I just sent you, it's okay. It lists some of my conjectures, and the great news. So they are all rather old conjecture on which basically no progress has been made, and that these conjectures are not so easy to disprove. And the wonderful thing is one of them has been solved. And why I say it's wonderful, it's because it sounded so unlikely. So I asked this question out of my experience, and I would have bet 100 to 1 that this cannot be true. But when you try to, the reason I printed this conjecture is when you try to disprove it, you realize you don't know what to look for. So who knows? And then a young guy, relatively young guy, his name is Antoine Song, had a marvelous idea, and he proved that thing is true. It's the most extraordinary result I've ever seen, because nobody would believe 1 second this can be true. So this is a kind of result you love because it provides order. It's not the monster living in the cave. It means there is some new phenomenon which explain that things are not as complicated as they could be. So there is order, and this is good. We will go forward with that. And that was difficult. It needed a really new idea. And the main lemma he proved, also something totally unexpected coming out of the blue. It's fabulous, you see. So I don't have that many great news. And another thing which is nice is, since I couldn't solve this conjecture, I made some related ones, and the related ones are not solved by his approach. So, which means there's still work to do, there's still other ideas to invent, and okay, some good people have been working on that for 15 years, and this is not solved. Okay, so all that to say, well, there is no other way to make progress. You try to understand, and when you see some kind of phenomenon which looks plausible, then you investigate it on simple example and more complicated example. And if you can't prove it and can't disprove it, you state a conjecture. And if you are lucky, it makes mathematical progress. But this is not obvious to state a right conjecture. Maybe among the so many problems I try to solve, you ask me, are there things that I came back? Of course, I come back to, and I come back. Okay, I will tell you one of my great discoveries. It's called the generic chaining. Now, the generic chaining, the chaining is a method to bound the supremum of a stochastic process. It's invented by Kolmogorov. Kolmogorov is really founder of probability theory, and so many important things were invented by Kolmogorov. Really a great man. So he has this method to chaining, and the idea of chaining is you approach what you want to do by different steps, and each step is a link in the chain, and the chain, it goes from you to the point you want to reach somehow. That's one way to put it. And chaining, it's done in the literature so many ways, but it turned out that when you want to control, when your process is a Gaussian process, there is sort of a canonical way to do, which you can learn in 5 minutes if it's explained to you. You literally can learn it and the proof that it works in 5 minutes. Now, this method was not known. So I started working on Gaussian process in 1983, and somehow I solved the big problem in 1985, but I didn't invent the generic chaining. I used some other much more complicated method. And then I wrote a book with Michel Ledoux about that, and I wrote simpler proof and so on. But then there are some issues which were not completely clear. And I came back to this issue 15 years after having solved the main problem. And while I'm very lucky because I discussed this issue, I had a partner to hear myself talking, where I exchanged mail with him. And while I discussed that with him, I said, oh my God, there is this method 100 times simpler than everything we had done, which is there looking at me in the face, and that I didn't see for 17 years. And other people worked on that topic for much longer, and they didn't see it either, you see. So the thing is, when you come back after a while, okay, especially me, I have a deficient long-term memory. Now, deficient long-term memory means I don't remember what I did. I have to retrace the steps. So in retracing the steps, it gives me a chance when I make a wrong turn at the point. Since I don't remember, this time I try another way, and this is a better one. I've been using that many times. Okay, another story. Now, this is less important. It's on a topic which was popular at some point, but which is, okay, it's a tiny little problem with inside the probability, problem of random Fourier series. Now, it's a Fourier, probably you know what is a Fourier series. Now, the coefficient of your Fourier series are independent random variables. So you get a random Fourier series, and when is it true that it converges almost surely? Very basic question. And so there were classical results about that. Jean-Pierre Kahn did many things on that. And then my good friend Gilles Pizier was very successful at the topic. But somehow my feeling was that he didn't really go to the bottom of it. So when I wrote the book with Michel Ledoux, there was a chapter of random Fourier series where I used different methods than they did, and which I found they were better. And then I went back to it, but this thing I learned around 1985, and I would say every 5 years I went back to it. And nobody at all looked at it because, number one, it's a sort of specialized topic. And then number two, the people who had worked on it, they were convinced their method were better, so they didn't look at it. And last time I looked at it was in 2020. I wrote it again one more time in writing my last book. And when I wrote my last book, so that must be the 5th time I was going back to it. I asked myself, but could it be true that, and that was a structure theorem that would show that the most complicated situation is in fact a mixture of two very simple, obvious situations. So it completely clarified the matter. And then it was not even difficult to prove, and it took me 40 years to think about that. You see, so that's why I'm saying don't be shy to go over and over and over again. Now, some people have a photographic memory, and maybe this system wouldn't work for them. I know, okay, for example, the late fantastic mathematician Jean Bourgain, you would ask him about something he did 20 years ago, he would be able immediately to reproduce it. which is a strength, but also a weakness, because he has no chance to get a fresh light of it. Now, of course, maybe Jean Bourgain doesn't need to get a fresh light on anything because he goes, why is a problem unsolved? Well, there can be some formidable technical obstacle. Okay, now that you have to have somebody. But quite often it's not that, it's that we didn't look in the right direction. Now, the generic chaining was something that I said you can learn in 5 minutes, but it was sort of not so easy to look in that direction. At least many people, including myself, failed to do that. So getting a fresh approach. Now, again, there is no algorithm to get a fresh approach. That's what I say in my text, fresh approach are better invented by 25, 27 years old people than by 60 years old. With 60 years old, you know it all, you can't have a fresh approach. New idea is sort of instantaneous. You say, oh, you see a little piece. Now, usually it's not a complete solution because the complete solution needs several progress. And the complete solution is a tricky thing because very often you think you got it and then you realize this is complete nonsense. So it takes a few days before you can fully enjoy your happiness. But the particular phenomenon that something happens in your brain which never happened before, and you feel this is something new that you learn. Maybe you are not the first human being to learn it, but from your perspective, it's something new. Now, this happened to me. I had a good period in my life, and when I was around 40, and this happened to me a couple of times a year for maybe 10 years. And not all of them are great ideas, but there are some advances. And each time, at least the way I felt, that's a great, let me tell you, the awareness, and of course, when you solve the problem, that's something else. But just the thing that something clicked together, perspective changes. So the work I did with the generic chaining and the Gaussian process, I had the feeling that this was completely closing the field. And now there have been some recent progress, which seems to indicate that, well, maybe not. If you look at things in a larger structure, maybe there is still many things to understand. So that's what's really fantastic. The frontier has moved, but the unknown are as much as they were before. You see, but on the other hand, to retrace the 50 years of progress, you can do it in a few months because it's so much easier once the right formulation has been found. So Absolutely. It's a lot of a mixed feeling I have, this place I thought I had built in stone forever. And I say, well, maybe it will disappear in the foundation of something better and will go, okay, number one, I don't know any history of mathematics. So I could repeat the commonplaces that Grothendieck is the best mathematician of the 20th century. Okay, I have a piece of evidence for that. The piece of evidence is Grothendieck, who has a very strange personality, wrote a book which I don't know the title in English. In French is Récolte et Semaille, which means thawing and harvesting. And it tells a lot of things about that. But some of it is rambling, but some of it is about mathematics. And he explained that he had 14 good ideas in mathematics, or 13. And then he listed them. And he added that the 13th, the last one, is not as good as the other one. Now, what happened is the last one in topological vector space, and that's an area which totally changed the area of functional analysis where I started. So that's a list of the 13 ideas of Grothendieck. So it gives me some pretty impressive picture about the contribution of Grothendieck. Now, for first-hand experience, I can tell you my experience with Jean Bourgain, because okay, now I hope you put it on the internet, because I want everybody to know this, you know.
Of course.
So Jean Bourgain, 2 years younger than I am, and he came to Paris early in 1979, and that's when I met him. He stayed in Paris, and so here are two. So I discussed mathematics with him a couple of times, and one time I have a problem which I didn't work so hard on it, but I spent 2 weeks thinking about it, and as a game, when we leave our office and we walk to the cafeteria, which is a 7-minute walk, I ask him, Jean, do you know this problem? And I explain the problem with him. And he starts thinking while we walk. And before we reach the cafeteria, he had the solution entirely in his head in the first contact. Now, this problem, okay, so that's the story of my first joint paper with Jean Bourgain. I wrote things down and it got published. And it's not a trivial result. I mean, later I had to referee papers claiming that they found a simpler proof. And the people who claimed they found a simpler proof just did not understand the difficulty. It was complete nonsense what they wrote. Okay, so that's okay. Second experience of the same story. Now Jean Bourgain was staying in my place for a few days, and one evening I asked him another problem. And this problem deals on a special case of Banach spaces, which are called Banach lattices. He didn't know a word about Banach lattices. So I asked him the problem, and after maybe 30 minutes, he says, does the Banach lattice have such and such property? I say, yes, that's one of the basic facts. Then I can solve your problem. Okay? And that's the second joint paper I have with Bourgain. So the way I describe that is the mathematical ability should not be studied on a linear scale. It should be studied on a logarithmic scale, because obviously there is absolutely nothing comparable in Bourgain's abilities and mine. He is just in another class as far as power of discovery. Now, sadly, maybe he didn't have the impact. Okay, he got the Field Medal and every possible reward, he got them. But my regret is that he put no effort in explaining what he was doing, which would have made his impact even better. So the few times I was successful on problem he studies is because I had some tool he didn't have. But much of my strategy has been under no circumstance I will look at any problem which Bourgain might be interested in, because it's obvious that I don't stand a chance beside him. But mathematics is a large field, didn't really bother me. I found other things to do. But okay, it's complicated. It's complicated, even though, some people, Bourgain was extraordinarily fast. Maybe there are people who are slower and still couldn't compete with him face on, but still can do important things. Okay, it's complicated, as I said. The hard thing is find where you belong, and a place which is not too crowded, but not too much exotic either. Very late on random Fourier series, that's a sort of piece of luck. The 47 years old problem I solved when I was 53, and I'm proud of having done a really good piece of work after age 50, which is not something so obvious. So, okay, I thought it's better better not trying to do after age 60. I really didn't try. Now, sometimes I cannot help, when these people solved my conjecture, I just so curious, I try to read what they did, but doesn't mean I'm going to contribute. And I know I cannot compete with the 40 years old. This doesn't make any sense. It's exactly, would you try to run a marathon at my age? Well, the thing is, there is the archive now. You can put. It's not a formal publication, but it's okay. You get your prior if you get your work registered and people can access it, and it gives you priority. So they should do that. But there are also small journals which accept small papers, and now, okay, that's a difficult matter because there is a proliferation of journals, and some of them are really junky. And this didn't exist in my time. There was in France, there was some small journal, and I published many papers there, which I knew they are not us shaking, but it's good. Okay, they belong to this kind of journal. I'm sure this still exists now. You see, publishing in the proceeding of the AMS has to be a good paper, but you will have decent journal which will accept less good paper. The thing is to find the right quality of the journal according to your paper. I think that's important. Don't put a good paper in a too bad journal because people will not find it. And of course, putting a bad paper in a good journal, if the journal is a good journal, it will not accept the bad paper. So the risk, there is no much risk on that. You see, the award is not important, is solving a problem which will establish you as somebody competent. Now, this paper I send you, which is called My Favorite Problems, please have a look. Please have a look at it. All these problems were already explained on my web page, but this is going to appear in a real journal, and maybe it will get a little bit more attention. And of course, anybody solving any of these problems, I'll go around shouting on the roof that they are very good people, and it may help them. And even when I'm not there, you see, these are 30 years old problems, which sort of make sense and on which nobody made progress. And okay, there is some difficulty. The person who solved my problem, I'm so excited about, Antoine Song. He is already professor in Caltech.
Oh,
Right?
okay.
He's about 40 years old. He did some excellent work in other direction. And it's a very interesting story because he heard in a lecture somebody asked my problem, and he became fascinated by it, even though this is not really his area. And he spent 2 years learning around that. And then he had this wonderful new approach. You see, okay, that's a better pattern because he's
Okay.
well established. If he spent 3 years on my problem and fails to solve it, he's not going to ruin his life. He's not going to be discouraged. Nothing bad will happen. Now he solved his problem. Maybe he will get
Yeah.
rewarded for that.
That's
But you don't want. Um, as a beginner, you have to solve problems which are a lower level.
mm,
Just not to get discouraged. You see, don't climb the Everest the first time you run. I mean, it's just a common sense. It's just common sense. You try easier stuff, and if you succeed, then you try harder one, and progressively. But don't start something which going to discourage and where your odds of success are. Let us say they are small, of course, because nothing is impossible. You see, I have some question asked in that paper. I cannot say a completely natural question, but I cannot say I spent more than 15 minutes on that. I looked at it for 15 minutes and my mind was totally blanked. So I moved to something else. Now maybe somebody will look at them for 15 minutes and will solve them. That's possible. It's just not very likely. You see, so don't put the odds against. You see, okay. Now I must have said that already, but say from the time I started doing research, which is 1974, until I really 2020, when I finished writing my books, uh, most of the days I spend all my energy working. Now, okay, well, that's what I say, work until exhaustion, but no more. So all my energy, but uh, the fuel is empty, just to stop. There's no point trying to. It's not going. It's going to be counterproductive. So watch movie, take care of your kids or whatever, and okay. With the interest of my life, I was interested in traveling, and traveling is a good thing because you basically cannot think mathematics. So it forces you to really relax. And when you come back, you can start afresh and make some progress. But it's
Yeah.
complicated, First time I traveled in India in 1981, and then I one night actually I slept in a Hinduist temple, and then one of my problem came back to me, and I couldn't help thinking about it. And then I got an idea in the panel. Okay, it's a small idea, but I could simplify a proof made by a very respectable mathematician, and I was happy of that. Okay, but that's this problem forced itself upon me, because otherwise I would not on purpose try to think mathematics. I would try to relax. The thing you have to okay, but again, everybody is different. Now, the one thing I can tell you, I asked my good friend Vitali Milman, who happened to know many of the greatest mathematicians, like people like Misha Gromov, he knows very well. He knew Vladimir Arnold, who was a great mathematician. So I asked Vitali, these people, are they all working very hard? And he said, there is no doubt whatsoever. They are all working very hard. I know one guy who pretended he was not working very hard. Is John Conway. Maybe you heard of John Conway, the guy who invented the game of life. He invented the game of life. He invented the Conway group. That's the absolute genius. He had this fantastic idea. And then now probably he was pretending that in an interview he said, I'm loafing all day. I'm staying on my couch looking at the ceiling, and it's just, you would be disgusted if you see me. And I think he was, posing like that. I'm not sure that he didn't work very hard.